Okay, so we're continuing to solve trigonometric equations. And with these, excuse me, they'll follow more, I think, some of our algebraic patterns. Like we're going to need to know how to factor for some of these and different things like that. So in A, okay, we want to solve sine squared theta minus 1 equals 0. So how might I start this problem to solve it? Okay, we could do that. All right, we could say sine squared theta equals 1. We isolated sine squared theta, and now what? We can do what? Take the square root of both sides. So we get sine theta equals what? Not just 1, but plus or minus 1. Okay? And so we ask ourselves, well, where does that happen? Very good. Okay, theta equals pi over 2, 3 pi over 2. All right, and there we are. Okay, so we can do that when we have a quadratic equation where we have just our squared term and the constant. We can do what we call extracting square roots. So we move the constant to the other side, took the square root of both sides. That works out okay. All right, so that was good. We also, just for reference, could have factored this. Okay, sine squared theta minus 1 equals 0. This factors as sine theta minus 1 times sine theta plus 1. We've been talking about this pattern, right? And then we set each of these factors equal to 0. We get sine theta equals 1. And so we know that means theta is equal to pi over 2. And then sine theta equals negative 1. And theta equals 3 pi over 2. Okay, so we get the same things, just two different ways. I factored in that second method. Okay. Questions about this one? All right, for B, we've got 2 cosine squared theta plus cosine theta minus 1 equals 0. Okay, for this one, what do you think we can do? We're going to need to factor, right? This is just like factoring 2x squared plus x minus 1. Okay, except instead of x's, we have cosine theta. Okay, so how would we factor this? Well, the first terms are going to have to be 2 cosine theta and 1 cosine theta, right? Because the only factors of 2 are 1 and 2. Okay, and then the last term is going to have to be a what? In both of them. Okay, one of them is going to have to be positive, one's going to have to be negative. Okay, how do we decide which is which? Okay, well, so we're going to make this one positive. That'll give us plus 2. And then this one negative. That'll give us minus 1. 2 minus 1 gives us 1 cosine theta equals 0. Yes. Okay, now we apply the 0 factor property. We set each factor equal to 0. Okay, 2 cosine theta minus 1 equals 0. And cosine theta equals negative 1. Okay, all right, cosine theta equals negative 1. Where does that happen? When theta is equal to where? Pi. Okay, very good. And then 2 cosine theta equals 1, or cosine theta equals 1/2. Where does that happen? Okay, 60 in radians, that's what? Pi over 3. Is that the only place between 0 and 2 pi? Okay, it also happens in quadrant 4, so that's going to be 5 pi over 3. Okay, so we get 3 solutions for this one. Okay. At pi over 3, 5 pi over 3, and pi. Questions about that? Okay.
So from all these, we find the solution between 0 and 2 pi.
Yes. Yes. Okay. All right. And C gets a little interesting because we have both cosine and sine in there. And it'll be easier for us if we have just one. So which one do you think we should get rid of, cosine or sine? Okay, let's get rid of cosine because we already got 2 other terms involving sine. We've got cosine squared theta. I got my formula sheet in my hand. Okay, what do you think we could substitute for cosine squared theta? Mm, no, not -1. That's not true. But I think you're looking in the right area. Cosine squared theta is equal to what? What is it? 1 minus. Very good. Cosine squared theta is 1 minus sine squared theta. Okay, and then we got minus sine squared theta plus sine theta equals 0. All right, and so we get 1 minus 2 sine squared theta plus sine theta equals 0. Okay, usually we want to put these things in order of descending power. So I want that sine squared term to be first, and we prefer for that leading term to be positive. So I'm going to do 2 things. I'm going to multiply through by -1, and I'm going to rearrange my terms. So when I multiply through by -1, I'll get 2 sine squared theta minus sine theta minus 1 equals 0. Okay, so I changed the sign of each one and then put them in order of descending power. So I've got my squared term first, and then my first degree term, and then a 1. And then hopefully we can factor this. Okay, this would factor as what? 2 sine theta. Okay, plus 1 you think? Okay, and then sine theta minus 1. Okay, that looks great. So we set each of these factors equal to 0. 2 sine theta plus 1 equals 0. I get sine theta equals -1/2. So theta must be what? The reference is pi over 6. We're going to be down in quadrants 3 and 4. So we get what? 7 pi over 6. Very good. And 11 pi over 6. Okay. Then we also had sine theta equals 1. So we know that happens when what? Theta is equal to pi over 2. So we got 3 solutions for this one as well. Okay. Questions about that?
So in the second step, where it's 1 minus 2 sine squared theta, you're multiplying by a positive 1?
Right here? Now I multiplied by -1.
Okay, why -1?
Well, because Otherwise, we would have had negative 2 sine squared theta. And we don't like to factor when that leading term is negative. So I wanted to make this positive. Okay. All right, other questions? Okay. What about D? Okay. What issue do we have? We had this issue in the last problem. We got sine and cosine. We don't want that, so what should we do first? Yep, change sine squared, and we're going to change it instead of cosine because that's pretty easy to do, right? Sine squared theta is equal to what? 1 minus cosine squared theta. Okay? And so we get, if I bring everything to the other side, because I want my leading term here to be positive, so we get 0 equals cosine squared theta plus 2 cosine theta. And then if I subtract the 1, we get plus 1. Is that right? Okay. This one actually is a perfect square, right? It's cosine theta plus 1 squared. Right? That fits one of our factoring patterns. A squared plus 2ab plus b squared. Okay? But however you need to factor it, that's what it comes up to. And so we say cosine theta plus 1 equals 0. Where? Oh, but 2 minus 1 is positive 1. We got a 2, and then we subtracted 1, the positive 1. Okay? So we got cosine theta equals negative 1. So theta is equal to what? Just what? Just pi. Right? Theta equals pi. Questions about that? All right, we got E, F, G, and H. Okay. These really aren't that bad. E, I mean, we're doing the same thing kind of over and over. What do you think we should do first in E? That's it. Okay, if you see one of these functions squared, you need to think about our Pythagorean identities, right? So, when I see cosecant squared theta, I'm going to look on this paper. It says 1 plus cotangent squared theta is equal to cosecant squared theta. So we get 1 plus cotangent squared theta. Okay, right? Equals cotangent theta plus 1. Okay, I'm going to bring everything to one side. So I get cotangent squared theta minus cotangent theta, and that's it, right? If I subtract 1 from both sides, it's going to be equal to 0. Now what can I do? What can we do to solve this? Once we set an equation equal to 0, usually our next step is to factor. Well, beyond linear equations, okay? When we're looking at second degree equations, we want to factor. So how could I factor here? Factor out what? cotangent theta. Very good. I'm left with cotangent theta minus 1. Okay, so I need to know where cotangent theta is equal to 0 and also where cotangent theta is equal to 1. I said each factor equal to 0. Okay, where is cotangent equal to 0? Yes, very good. And also, very good. Okay, what I was thinking about was, well, cotangent is cosine over sine, right? So cotangent is going to be equal to 0 when cosine is equal to 0. Cosine is equal to 0 at pi over 2 and 3 pi over 2. Okay. Then where is cotangent theta equal to 1? Where? Not 2 pi. Pi over 4 and 5 pi over 4. Am I right? Yes, right? So these would be our solutions. Questions about this? Okay, good. All right. Now F might be a little tricky. We've got sine and cosine. We don't have an easy way to convert between sine and cosine. And that root 3 is not terrible, but not what we want. So here's what I'm going to try. I'm going to bring cosine to the other side. So we get root 3 sine theta equals 1 minus cosine theta. And then I'm going to square both sides. Okay, why might I do that? Okay, what was it? I heard a couple of things. Okay, we will get rid of the square root of 3, and then we'll have sine squared, which I can convert to cosine squared. Just make sure when you square both sides, we do it correctly. So on the left side, we get 3 sine squared theta. And on this right side, I get what? I'm squaring both sides. More than that. What else? Come on. 1 minus 2 cosine theta plus cosine squared theta. Right? If you go and do FOIL, that's what you would get. Or if you know the pattern, this is what we would get. Okay? And now I'm going to convert sine squared theta to 1 minus cosine squared theta. Okay, so we get 3 minus 3 cosine squared theta equals 1 minus, well, let me go ahead and turn these around if it's okay. Cosine squared theta minus 2 cosine theta plus 1. Okay. We add 3 cosine squared theta to both sides and then also subtract the 3. So I get 0 equals 4 cosine squared theta minus 2 cosine theta. 1 minus 3 gives me what? Okay, minus 2. Okay. Then we want to try to factor that. Okay. Questions so far? Okay, so we got 0 equals, I'm going to factor off a 2. We get 2 cosine squared theta minus cosine theta minus 1. I think we've seen something like this already today. 2 cosine theta, I'm going to have a 1, and I'm going to have cosine theta 1. Okay, so we do minus, plus. Does that work? Yes, okay. So I think we know now, we should know, we get cosine theta equals minus 1/2, and we said that that happens where? Theta equals 2 pi over 3 and 4 pi over 3. Is that right? Okay, I'm thinking about my reference of pi over 3. Okay, and then also we had cosine theta equals 1. That happens where? Where's cosine theta equal to 1? Either 0 or 2 pi, depending on whether or not which one is included. So let's just say 0. Okay, it just depends on what the instructions in the problem said um, that'll get us there. Okay, questions about this?
Can you pull your work back up?
Yes.
Were you getting cosine theta equals negative 1/2? Why would it be positive?
Right, I set it equal to 0, so we'd bring that 1 over, that'd be a negative 1. Okay. All right, other questions? Okay. Multiply which part? By 2. Okay. All right, we got G and H. I think we can make it. Then we're going to talk. Okay, sine 2 theta. Okay, I'm going to look on my formula sheet, and I'm going to rewrite that as 2 sine theta cosine theta. Ooh. All right. And I know the next step you might think of would be to divide both sides by cosine theta, but we're not going to do that. We try to avoid dividing by a fraction. I'm not a fraction, a variable, because we don't know the value of the variable. And if it happens to come out to be 0, then we've just made a very, terrible error. We can't divide by 0. So as much as possible, we try to avoid dividing by variables or variable terms. So instead, I'm going to bring that cosine theta to the other side. Okay, subtract cosine theta from both sides. Now what can I do? What have we been doing in almost every problem? Factoring. I can factor out cosine theta. We're left with 2 sine theta minus 1 equals 0. And so we need to know where cosine theta is equal to 0 and 2 sine theta minus 1. We need to know where it's equal to 0. So we get theta equals what? Where's cosine theta equal to 0? Pi over 2 and 3 pi over 2. Okay, and then we need to know where sine theta is equal to 1/2. Where does that happen? Very good. All right. And those are our solutions. Notice if we had divided by cosine on both sides, we would have missed two solutions. Okay, so this was the best way to do it. And finally, in H, cosine 2 theta, I'm going to make a substitution. And since I'm going to substitute 1 minus 2 sine squared theta from my formula sheet. Right? What is it? 1 minus 2 sine squared theta. Okay? Equals 2 minus 2 sine squared theta. Okay? Well, let's say I try to bring the sine squares to the same side. So let's say I add 2 sine squared theta to both sides. Well, when I do, I get what? 1. No, they're both negative. So if I add, they cancel out. So we get 1 equals 2. Is that true? No solution. So, yeah, not all of them work out. Questions about that?